All right, last week we have you have learned about the convolution properties, right? Convolution properties. The first properties is the commutative. Okay, commutative properties. This means that doesn't matter the convolution xt convolute with the hash t or hash t convolute with the xt. Doesn't matter which signal get flipped. Okay, because the role of the input xt and the input impulse response ht can be interchanged. So this is the commutative. And for the example, we also go through the example 2.17. Okay, 2.17. Okay, this is example 2.17. You have the xt and the hash t. Okay, xt and the hash t. So xt is the ut and hash t is the exponent power of negative alpha tut. So we do the convolution xt convolute with the hash t. So this one, first of all, you change the time index. Okay, so means that you from the xt you change to x tau, hash t you change to hash tau. Okay, so all the terms in t you change to tau. All right, so the second step would be the folding. Okay, folding, this means that you fold the signal either one, either you fold the hash t or hash tau. So in this case we choose to folded the hash tau, so we get the hash negative tau. Okay, so hash tau you obtain like this exponential, and negative tau is the negative side. And then after that is a shifting. Okay, shifting, you shift the t unit. Okay, so that there's no interchange, no close uh no interchange with the another signals. And then multiplication, so this is the multiplication, so the signal hash t minus tau will go through from negative infinity to positive infinity. Okay, it will pass through this signal x tau. Okay, so therefore they have three cases. The first one is a t less than 0. Okay, there's no overlapping. And then after that t more than 0, which has the overlapping. So this is the overlapping area. Okay, this is the overlapping area. And then you perform, the last step is to perform the integration. It means that if t less than 0, there is 0. Okay, why t obtains 0? Because there is no overlapping. And then for t that more than 0, there is overlapping, okay, from the range 0 to t only. So you calculate this overlapping area, then you obtain your answer. Okay. And example 2.18 actually is to show you the question want you to reverse the order of the convolution. So example 2.17 to show you that xt convolute with the ht. Now they want you to do ht convolute with the xt, whether you will get the same result or not. Okay, the same question, just that you flipped the xt. Okay, you flipped the x tau. So of course, when you hash t convolute with the xt, okay, so the formula also change to hash tau, okay, xt minus tau d tau. Right. So for the first step, of course, is the change the time index from the xt to x tau, hash t to hash tau. This one is the same as previous, just that you notice here from the step 2 for the folding, okay, you change the x minus tau. Okay, this is the one you change. So you x tau you obtain like this, then x minus tau is the negative side. Then of course when you select the x negative tau, shifting also change to the x. Okay, you shift the x minus tau, shifted t units. So you obtain this one. And then multiplication. Okay, same step. And then this xt minus tau will go through from negative infinity to positive infinity, and check which one is overlapping. Okay, if for t that's less than 0, there is no overlapping. Okay, there is no overlapping. So this is the xt minus tau, and this one is the hash tau. Okay, this one is the hash tau. So of course there is no overlapping. Okay, so when there is no overlapping, of course you will get 0. Right? So for case 2, for t that more than 0, so this means that the xt minus tau pass through 0. So this means that it's more than or equal to 0. So any value that more than 0 is like this. So is there any overlapping? Yes, this is the overlapping area. So this signal xt minus tau multiply with hash tau. So what will happen? So this is the overlapping. Okay, exponent power of negative a tau u tau from 0 to t. So from here you can step 5 do the integration. For t less than 0, of course you will get 0 because there is no overlapping. Then for t that more than 0, you will have to calculate from 0 to t. Okay, 0 to t exponent power of negative a tau d tau. Okay, you integrate this one. So you obtain exponent negative a tau divided by negative a. Okay, minus with 1 because exponent 0. When you substitute tau with 0, you have exponent 0, you get 1 divided by negative a. So you obtain 1 over a in the bracket 1 minus exponent power of negative a t. So then you write down the final answer. Then you check again. Is this final answer okay same as the previous one? Same as the previous one or not? Okay, you check. Okay, this one. It's the same, right? So what is mean by this? Using this example. So even you flip the hash tau convolute with x tau or x tau convolute with the hash tau, you will get the same answer. This means that it's a commutative. Okay, so this proves the commutative properties. This means there's no change, okay, no effect on the output. Doesn't matter which signal is get flipped. Okay, so after that you go through the second properties. That is associative. So for associative property, there is the hash1t convolute with hash2t, and then in the bracket convolute with the hash3t. Okay, so this is also same as hash1t convolute with in the bracket hash2 convolute with hash3t. Okay, hash3t. There's a missing hash3 here. Hash3t. It's not like this. Okay, there's a hash3t. Okay, so this is true for cascaded system. So hash1, then pass through hash2, then pass through hash3. Okay, so convolution can be applied in interconnect system. It's called cascaded connection. So it can be hash1. Okay, x pass through a hash1, you obtain a y1. Then pass through a hash2, you obtain y. Okay, so or you can say that xt, okay, insert into a system. The system is hash1 convolute with the hash2, then to produce the output yt. This one will be the same. Okay. Okay, if you write in the equation form, so y1, this one is y1 equal to x1, xt multiplied with h1. Then this y is equal to y1 convolute with the h2t. So the yt is this one, xt convolute with the h1t convolute with the h2t. Or for this one, or we can say that the xt convolute with the h1 convolute with the H2, okay, equal to YT. This is so-called the associative. Okay, for the associative, two cascaded system can be replaced with a single system with the overall impulse. So H can be represented by H1 T convolute with the H2T. Okay, so also applying by the commutative rules, you still remember the commutative for the first properties. So YT equal to XT, okay, convolute with the H2T and convolute with the H1T. So actually is uh okay, XT convolute with H1 and H2. Okay, so property number 3 is the distributive. Okay, distributive property is XT convolute with the H1 plus H2. Okay, if you multiply in, you will get XT convolute with the H1T plus XT convolute with the H2T. This is parallel. Okay, this is parallel. Okay, if you look at this one, this equation can separate into two. Okay, H1 plus H2. So if you multiply in, you will get XT multiply with H1T plus. Okay, this is the plus XT convolute with the H2T. So in this case, the total system impulse response is the sum of the separate impulse response of the parallel system. So this one, when you say parallel, so it's H1 plus H2. Okay, parallel is H1 plus H2. For the distributive, is the H1 convolute with the H2. It's slightly different. Okay, so this one is the exercise. You can do the exercise in the module, page 99. Okay, so please everyone do this exercise 2.4 as a homework. Exercise 2.4, question 1 as a homework. Okay, and then submit on next week, okay, before class, which is on 23 November. Okay, so there's one question here. So is there any question about the chapter 2? We have finished chapter 2 actually.
Doctor,
Yep.
can you extend the assignment due date for section 5?
Why?
Because the date set is 7 for tomorrow.
Okay. Okay. You don't enough time to do it?
Yes.
What if I give you until next week? 23 only. Another 1 week.
Can.
23, huh? Okay.
Okay, thank you, Doctor.
Alright. So don't forget a letter change. Everyone have to pass up with 23 November.
Doctor,
Yeah.
do we need a cover page, Doctor, for the assignment to submit?
Of
Or
course,
just submit the...
Of course, you need your name, your metric number. For the
Oh,
assignment, of course, you have said assignment 1.
okay, thank you, Doctor.
For assignment,
Doctor.
or typing?
Yeah, Li Heng?
Doctor.
We need to complete it by handwriting or typing.
Handwriting, okay. No, it's okay already.
Okay.
Doctor. Nak submit tu individual atau group untuk answer?
Untuk assignment. Assignment ke? Ke exercise? Kalau exercise individual.
Assignment.
Assignment hari tu saya cakap apa? In the group, right? A group of 4.
Okay. So hantar satu je lah.
Hmm.
Satu answer speech je
So
lah.
one
Okay,
one
okay.
group one. Assignment one group one.
Okay, Doctor. Thank you.
If for the exercise you have to do on your own. Because that is your own practice. For the assignments, I already assigned group for you. The group you can check at the author platform. Who is your group member? Okay? Any other question? If you have no question, I do have question for you, which is tutorial 2. Tutorial 2, okay, I want you to do question 1. Question 1, and then question 2. Question 4. Question 1, 2, 4. Let me see what else. 6. Okay lah, 1, 2, 4, 6. Then submit also together with the exercise 2.4 before 23 of November. Okay. Okay, you get it, class? Tutorial 2, question 1, question 2, question 4, question 6.
Puan,
Yeah.
dekat auto tu tak submit. Boleh tak Puan bukakan submit tu awal untuk tutorial 2 dengan exercise 2.4.
2.4. 2.4. Kenapa?
Nak submit awal before 33.
Boleh. Nanti saya createkan, you boleh submit lah.
Okay, thank you.
Okay. So, any question for this? If no question, we shall go to the chapter 3. Okay. Chapter 3 is about the... Shall I continue? Okay. So, chapter 3 is about the Fourier series. So, lecture 5 is about the exponential Fourier series. So, in chapter 3, we all talk about the Fourier series. Okay, Fourier series. And lecture 5 is especially on the exponential Fourier series. We have 3 types. Okay, we have 3 types of the Fourier series. So this is the important formula. English also available in the module. Okay, introduction. Okay, who created this Fourier series? Actually, if you at the page 107, 104, okay, let me see this guy. Okay, this is so-called Jean-Baptiste Joseph Fourier. So the name is Fourier series is named based on his name. Okay, This is the Joseph Fourier. So this Joseph Fourier has shown that any periodic non-sinusoidal signal can be expressed as a linear wet sum of harmonically related sinusoidal signal. So this Joseph Fourier introduced this Fourier series, okay, in which the periodic signal is represented as a function of frequency. Okay, how? Okay, the Fourier representation of a signal is also known as frequency domain. Representation can be used to perform frequency domain analysis. So Fourier series, don't forget, is to perform the frequency domain analysis, okay, of the signal. So frequency component represent the signal and in term of magnitude and phase. All right. Okay. A complex problem can be partitioned into a smaller and simpler problem which can be solved independently. So the total solution of such a complex problem is a sum of the simple solution. This means that all the complex solution actually is a combination of a single or independent solution. Okay, they combine it together and become a complex problem. So example of this technique is the Taylor series. Function ft is expressed in the form of constant, ramp function, parabolic function, okay, and so on. So this is the Taylor series. So if you can see that here, this is a combination 1 plus x divided by 1 factorial, then divided by 2 factorial. So this is so-called the Taylor series, which consists of the constant. Okay, the first one is a constant, ramp function, and the parabolic function. So if you look at here, this is the individual harmony and the combined harmony. So first of all, you need to know, okay, if individual harmonic is how it looks like. If omega naught, it looks like this. Okay, then 3 omega naught, the frequency is getting different. Okay, frequency is higher than 5 omega naught. Okay, and infinity. Okay, near to the one line. So the amplitude, of course, from the 1 omega naught to 5 omega naught, the amplitude is getting smaller. Okay, if 1 omega naught, the amplitude is higher. So this is the combined harmonic between these few individual harmonics. So this is non-combined, it's just omega naught only. But this frequency, okay, this harmonic is a combination of omega naught and 3 omega naught. This means this is omega naught, it combined with the 3 omega naught. Okay, so actually if you look at here, the big sine wave is omega naught, and the one at the top or at the bottom, okay, the peak there is actually from the 3 omega naught. Okay, similarly to the omega naught, 3 omega naught, and omega naught multiplied with 3 omega naught multiplied with 5 omega naught. So the harmonic here is from here. It formed at the peak, at the bottom peak. Okay, so when it goes to, okay, if omega naught, 3 omega naught may multiply up to infinity, it may nearly goes to a perfect result. Okay, the condition for existence of the Fourier series, how is the condition? How it exists? The Fourier series exists only if the following Dirichlet conditions are satisfied. So period, the signal xt is absolutely integrable over any period. This means that, okay, this means if the signal is absolutely integrable, so it's a Dirichlet condition. Okay, integration 0 to alpha a to a plus t xt modulus xt dt, that which is less than infinity. So means that integrable. So the signal st has only a finite number of maximum and minimum over a period. You have the finite number. You have the number, not infinity. And the signal xt has only a finite number of discontinuity over any period. Right, then we have so this is the condition for the existence of the distributed condition. And next we talk about a type of the Fourier series. So we have three types of the Fourier series. The first one is a trigonometry. Second is first one is a exponential. Second is trigonometry, and third one is amplitude phase. So this is mostly in this chapter we study these three topic. With these three type of Fourier series. So also quite common question to ask around these three Fourier series. So this one is a Fourier series in an exponential form. The exponential form of the Fourier series of a periodic signal xt with period t is defined as like this. So everyone have to remember this is the exponential form of the Fourier series. So this is the formula. Xt equal to the summation of the xn exponent power j 2 pi n over t over capital T t. So actually 2 pi over capital T is referred to the omega naught. Okay, omega naught. Normally we can write xn exponent power of j omega naught t also can. Okay. This Sn this Sn actually is referred to Sn 1 over t xt. Okay, this xt is referred to the question given exponent power of minus j 2 pi n over t dt. Okay, and this one okay, the periodic xt be the periodic continuous time signal. The exponential form of the Fourier series, okay, is written in this way, it's the same. And then it can be expressed in the polar form. So this is the polar form. Okay, modulus xn refer to the magnitude of this xn, and this one refer to the phase, phasa, or the degree. So this is in the polar form, whereas this one is in the complex, okay, complex number, so which is in the rectangular form. You can, if you write in a rectangular form, so if you given a complex number, you can find this magnitude and the phase via this formula. Okay, a n square plus b n square square root to find the modulus xn, and the phase is the inverse tangent of these two value bn over an. Okay, so this is the formula. So don't forget this formula, you also need to remember, okay? Okay, example 1. Example 1. Okay, given a signal xt equal to 1 plus sine omega naught t plus 2 cos omega naught t plus cos 2 omega naught t plus pi over 4. So in this question, they ask you to get the Fourier series coefficients. Okay, Fourier series coefficients. So let me show you how to do it one by one. I stop sharing first. Can you see my screen, class?
Boleh.
Yes, Doctor.
Okay. So if you refer to the this example, okay, okay. So to solve this question, you need to use this Euler formula. So you need to know this formula. So the first one is, because in this question you have the sine and the cos. So you need to know cos omega naught t equal to what? You change to the exponent. Okay, so 1 over 2 for the cos omega naught t, you change to the exponent, you get 1 over 2 exponent j omega naught t plus exponent minus j omega naught t. Okay, this one you need to remember, as well as the sine omega naught t equal to 1 over 2j. Okay, it's 1 over 2j. Exponent j omega naught t minus, okay, this is minus, exponent minus j omega naught t. So this formula you need to remember. Okay, next is how to solve this. Okay, so xt equal to, you copy from the question. So we substitute this cos and sine into the question. So 1 plus, okay, the first one is a sine omega naught t, right? Sine omega naught t, you change using this formula. Okay, so it's 1 over 2j exponent j omega naught t minus exponent minus j omega naught t plus, okay, after that plus with 2 cos omega naught t. Okay, 2 cos omega naught t, and then you use the cos. Okay, so 2 and 2 you can cancel out, so I left exponent j omega naught t plus exponent minus j omega naught t, and then plus with the third one. Okay, the third one is the cos. Okay, you also use cos. So cos is 1 over 2 exponent j. Now is a 2 omega naught t plus pi over 4. Okay, the pi over 4 you also need to collect. Alright. Is it okay? Then after that, this is equivalent to, okay, you 1 plus, you just collect, okay, all the exponent j omega naught t. So if you look at here, here you have exponent j omega naught t, this one also j omega naught t. So you collect all this exponent j omega naught t. This one is minus, so this one also minus. You collect together. Okay, so you have this one for j omega naught t, you have 1 plus 1 over 2j exponent j omega naught t. Okay, and then after that you want to collect for the exponent j omega naught t for this part. So I have 1 minus 1 over 2j exponent minus j omega naught t. Okay, plus with, okay, this one and this one. So 1 over 2 exponent j to omega naught t exponent, okay, j pi over 4, okay, plus with 1 over 2 exponent minus j to omega naught t, then exponent minus j pi over 4. Okay. So until up to here actually is enough actually. You can just stop here also can. Okay, so how to find the Fourier series? How to find the Fourier series? Okay. Okay, from here you know that this one. Okay, I would say that you rearrange the coefficient and group the terms of omega naught. So I write here, you rearrange the coefficients and grouping the terms of omega naught minus omega naught 2 omega naught minus 2 omega naught. If you look at here, maybe okay, if you look at here, you have the, let me draw the line. Okay, if you look at here, this is omega naught, and this is minus j omega naught, and this part is 2 omega naught, and this part is minus 2 omega naught. Okay, so you collect all these terms. So in the end, you will obtain. So this is a Fourier series coefficients. So x0, okay, this one is nothing. So you obtain x0. x0 is referred to 1 and x1. So this is omega naught is referred to x1. Okay, so we have 1 plus 1 over 2j. Okay, or you want to rewrite and you want to bring up the j, you can write as 1 minus 1 over 2. You can say this is j lah. Okay, then so this part is x1. For this part is x minus 1. So x minus 1 refer to 1 minus 1 over 2j, also equivalent to 1 plus j over 2. Okay, you know why this is like this? This is because 1 over j equal to negative j. Okay, this one. Alright, and then what else? x1, you have the x2 because you have 2 omega naught. So x2, what do you have? x2, you have 1 over 2 exponent j pi over 4. Okay, exponent j pi over 4. Okay, and then x negative 2. Okay, you have if this one, okay, class, if this one you want to change it to this is in exponential form. If you want to change it to a complex number also can. Okay, do you know how to change to a complex number, class? From the exponential, do you know how to change to the complex number? Because later on you need to find the magnitude and the phase, right? You need to change to a complex number. So let me show you here. Okay, so this one you can change it using the from the exponent Euler formula, also from the exponent to the cos and sine. This one you can change it to 1 over 2. Okay, the cos is pi over 4, right? So it's cos pi over 4 plus j sine pi over 4. Okay, you can press the calculator using the radian. Okay, radian, you can get it. So you get 1 over 2. Okay. Okay, so you can change it to the radian. Change it to the complex number from the exponential to a complex number. But in fact, if you want to, from this graph, if you want to read for the magnitude, okay, so this is actually the magnitude. This part actually is the magnitude. You can straight away get it from the this exponential reading. This is magnitude, and this is the phase. Okay, this is the magnitude, and this is the phase. Phase is pi over 4. So pi over 4 means what? How many? Plus pi over 4 is how many? 180 divided by 4. So it's about 45. So it's a positive j pi over 4. So it means that the value is positive 45. So this means that the phase is positive 45 degree. And magnitude is, okay, so if I want to write here that magnitude is 1 over 4. Magnitude is 1 over half, but the phase of the x2 is 45 degree directly without change to the complex number. Also you can get it directly. Okay, so for the x minus 2, you have 1 over 2 exponent minus j pi over 4. Okay, so this is the coefficient. Okay, if you want to get the magnitude, okay, so magnitude is what? So the modulus x2, you get half, and the phase of the x2, sorry, x minus 2. Okay, so this one is minus 45. Okay, and then what else you obtain? Okay, no more. X1, so this is x2, x negative 2. Okay. Okay, for this one, if you look, if you have if for example, if you the first one, x1, you already in a complex number. So if you're in a complex number, you need to find the magnitude and phase. So you need to follow the formula. Okay, let me show you here. Okay, for the x1, if you want to get the formula, and if you want to get the magnitude, so the magnitude of the x1 is equal to 1 square plus -1/2 square root. So what is the answer? This is 1.12. Whereas for the phase, you use the formula inverse tangent 0.5 divided by 1. Okay, so you get, what do you get? -26.5 degree. Then for the x -1, so you have the 1 plus j/2, so it's 1/2 square. So this is equivalent to also 1.12. And then the modulus for the phase of the x -1, you obtain inverse tangent 0.5. It's a positive, right? Positive, correct. Positive 0.5 divided by 1. So this is equal to 26.5 degree. Okay, class? Do you get it?
Okay.
Okay, Doctor.
So after you find the Fourier series coefficients, okay, x0, x1, x minus 1, x2, and x minus 2. So after that, you need to do for the magnitude. Okay, the blue color one is the magnitude and the phase. You need to do the magnitude and the phase for each one, and then you can actually plot the graph. Okay, you can plot the graph. For the 0, you get 1, and then you have 1.12 for number 1, and then for x2 you get 0.5. And then here also the same, 1.12, then 0.5. Okay, so this is for the magnitude. Then another one is the phase. Okay, it's the phase. So this is the phase of the xn. Okay, for the first one, for the x0 you don't have the phase, so it's 0. And then for the x1 you get -26, right? -26.5. Okay, and then x2 you obtain 45. Okay, and then x -1 you get positive 26. And then x -2 you obtain -45. Okay, so basically it's a common question that the question asks you to plot the magnitude and the phase. Alright, so any question on how do you obtain the magnitude and phase as well as the Fourier series coefficients?
Ya kot.
Boleh ya?
Boleh.
Boleh, Doktor.
Okay, then we go to the second question. So second question is about what? Okay, there's some important notes for the Fourier series coefficients. So represent in magnitude and phase. So this one you can plot in a graph. A positive value is a complex conjugate of a negative frequency For example, the fifth harmonic has a coefficient of x5 and x minus 5 is equal to the conjugate. This means that the coefficients is conjugate. So for the x5, positive 5 and negative 5, so let's say the value of x5, the value of negative 5 is the conjugate of the value of x5. And then the positive frequency magnitude and the negative frequency has the same value and the phase are odd. Okay, let's say this is modulus x5 equal to modulus x negative 5. So the phase, we're talking about the phase of the x5 equal to negative phase of negative 5. Okay, negative phase. So this means that the positive frequency magnitude and the negative frequency has the same value and the phase are the odd. Okay, it's totally upside down lah. The odd is upside down. Okay, any question before we stop a while? Okay, for tag 5 and then we continue with the example 2.
Tak ada.
Okay, if no question, we stop for 5 minutes, then we continue again. Okay, class, welcome back. So this is example 2. Given a signal xt is equal to 3 cos pi over 3t. Then what are the coefficients? And then another question is sine cos. Yeah, it's example 2. Okay, so we will discuss this question. Okay, so this question is let me write down the question first. Okay, so again we use the formula of the Euler formula. Cos omega naught t equal to half of the exponent j omega naught t plus exponent minus j omega naught t. Okay, we use this formula. So xt.
Doctor, you have off your mic.
Oh, okay. Okay, thank you. Okay, so is it starting from first? I didn't say say anything. You can't hear anything.
Yeah.
Okay. All right. I will repeat again. So example 3.2. The question is xt equal to 3 cos pi over 3t. So we use the same formula, the Euler formula, where cos omega naught t equal to half of the exponent j omega naught t plus exponent minus j omega naught t. So we use this formula and substitute in the question. So xt equal to 3 cos. So 3 times half of the exponent j, okay, omega t is pi over 3t plus exponent minus j pi over 3 t. Okay, so this will equivalent to 3 over 2 exponent j pi over 3t plus 3 over 2 exponent minus j pi over 3t. All right. So from here we have two coefficients, which is this one and this one. Okay, we have three coefficients. And we have two discrete frequency. So two discrete frequency. The first one is the exponent, positive j pi over 3t. And another one is exponent minus j pi over 3t. And then the Fourier series coefficient is x1 is 3 over 2. Okay, refer to this one. And then x minus 1 is also 3 over 2. Okay, so this x1 and x minus 1 both are the real value. So we can plot the magnitude only because it's a real value. So in magnitude plot only, no need to plot the phase, as the phase angle are 0. Okay. Right. Class, I want to ask you, if this signal is a periodic signal? Class, I want to ask you, if this signal is a periodic signal?
Yes.
Okay, what is the fundamental period? You have learned what is fundamental period, right? So what is the fundamental period for this signal? You still remember? T naught equal to 2 pi over omega naught. So 2 pi over 3. So if you rearrange, you get 3 over pi. So cancel out, you get 6. So 6 is a periodic signal. Okay, any question for this question? Any question?
No, no. Ada.
Okay, if no, then I move to next. Okay, summary. Okay, there's a summary. Okay, there's another signal. Just now is the, if the cos, that one is a even signal. If you look at your module, I think you have another example. The another example is example 3.3. Okay, example 3.3 also the same, but I won't repeat the same things. Example 3.3, you also substitute. Let me share with you example 3.3. Okay, this is example 3.3 at 3.2, and this one example 3.3. It's still the same. You use the sign to substitute in the exponential. You use the exponential to substitute in the sign. Okay, so you obtain this one. Okay, exponent these two discrete frequency. This is a discrete frequency obtained from here. So you have the x1 is 3 over 2j and x negative 1 is 3 over 3j over 2. Okay, this 3j over 2 also equal to 3 or negative 3 over 2j, that is the same. So and then you plot the xn. Okay, I want all of you to make a correction of this graph. Supposedly this is just xn.
Doctor,
Doctor,
you're
your
actually not
screen.
sharing your screen.
I'm sorry for that. Okay, just now as you understand what I'm talking, right? Example 3.3, you can look at your things. But for the correction, you can change this one. This one is not modulus. This one is just the xn only. If modulus, it will be look like this. Okay, this is the modulus. All become positive. Okay, if xn there is a positive negative, but modulus all become positive only. Okay, then you go back to the slide. There's not here. Okay, the summary of the example 2 and example 3. So even periodic real signal. So this even is referred to the sine wave lah, sine wave. So if the periodic signal xt is real and even, okay, then the Fourier series coefficient are real and even in the frequency domain. Okay, so when plotting the xn graph, one just need to plot the magnitude graph only, and there is no need to plot the phase angle, as the phase angle are 0. Just the one that I show you, example 3.2, there is only positive. There's only the positive graph. Okay, there's magnitude graph only. There is no phase angle graph. So for the odd, that one is the for the odd graph. Okay, odd periodic real signal. If the periodic signal is real and odd, okay, then the Fourier series coefficient are imaginary and odd in the frequency domain. So this means that, for example, the value of xn, in case you have xn equal to negative x negative n, the value of xn are imaginary value and they are odd in the frequency domain. So when we're plotting the xn graph, one just need to plot the imaginary magnitude graph, and there's no need to plot the phase angle, as the phase angle are j. Okay, j means the 90 degree. Okay, so this is this summary also in page 111 in your module. Okay, so next example is about example 3.4. Okay, example 3.4. Okay, example 3.4 I want to show you also, and example 3.5. Okay, this one. So now I will show you the example 3.4 in your module. Okay. So example 3.4, the graph is like this. Okay. Alright, so in this question, they ask you to find the Fourier, determine the exponential Fourier series expansion of this signal. So first of all, you need to know what is the of xn, okay, for the exponential Fourier series. So this is the formula. Xn equal to 1 over T naught, okay, alpha plus T naught. Okay, most of the practice I will request you to write the formula first so that you get familiar with the formula. Okay, you get familiar with the formula. So xn equal to 1 over T naught. Okay, so you want to, okay, let's say if you look at here, the one cycle is from where to where? Is from here to here, right, class? Am I right?
Yes, Doctor.
Okay, so if I do like this, will it be the same? This is A. If I do like this, will it be the same? Same or not same?
Which one, A or B, Doctor?
Ah, is it A same as B?
No, doctor.
Okay, why?
Yes, yes, same, doctor, same.
Same, right? Okay, wait a while. Is A same as B? If you look at here, okay, I use the different color, okay? Okay, if A means that if A to if the for the A, this one you have the value, okay, and this one also you have the value of half here. Okay, so means that you need to do 2 times of integration because from 0 to tau over 2, and then before that you have to from here to here, correct or not? Can you see that?
Yes.
And then if you use the B, okay, I use what color I want to use? Black color. Okay, okay. If B, this means that it's from here to here. So the integration only from here to here. Okay, and this part is 0. So I only take integration is 1 time only, where from negative tau over 2 to tau over 2. This means that I shorten the integration. I don't need to do 2 times, because if you choose the A, I will have to do from here to here and then here to here, because this is only the complete cycle. You get what I mean here? If you choose B, there will be from here, okay, to here only. But the range is still the same lah. Okay? So let me continue. You understand now, class? You understand?
Again, Doctor?
Okay. I just want to say that if you want to use A and B also the same. Just that if you okay, now I choose if I choose to write A, okay, if you choose A. Okay, you choose A. Let me see. You say choose A. If you choose A, mm, you choose A, you need to write from the xn 1 over t naught. Okay, A is from 0 to t tau over 2, and then xt, right? Xt exponent minus j 2 pi n t over t naught dt. Then plus with, okay, 1 over t naught. Okay, this one is you need to know the value here lah, the value here, the value here. Okay, you need to know the value here. This value should be t naught minus tau over 2 lah, until t naught. Okay, if you choose B, then my xn equal to 1 over t naught. Okay, this is from the formula. Okay, minus tau over 2 to tau over 2 xt exponent minus j 2 pi nt over t naught dt. That's it. You can use A or B also can. Just that I will choose B because it looks easier than A, because you don't need to do 2 times of integration. Okay, that's it. You got it?
Yes.
Okay. So I won't use this one. I won't use this one, so I use B. So I can continue. Okay, 1 over t naught. Okay, from tau over 2 to tau over 2. The xt is the value of the, okay, this is the 1 here. Okay, this is the 1 here, xt, because this is the xt. Okay, xt, the value here is 1. So 1 multiply with exponent minus j 2 pi n t over t naught dt. Okay, so 1 over t naught, I integrate this thing, this part, so I obtain t naught over minus j n 2 pi. Okay, then I remain, after integration, I remain exponent minus j 2 pi n t divided by t naught. So the integration from minus tau over 2 to tau over 2. Okay, yang ni boleh ikut ke? Can you follow this part? Okay, if no question from you, I assume that you can understand. So after that, you just substitute the value of tau over 2 and minus tau over 2 into t. Okay, so this one you can cancel out. So you just left negative j n 2 pi, and then my exponent minus j 2 pi minus n 2 pi over t naught. The t you substitute with tau over 2. Okay, and this one you substitute with minus tau over 2. Okay, so what will happen? So you still remain minus j n 2 pi. Okay, this one can cancel out. This one cancel out. This one also cancel out. So you left exponent minus j n pi tau divided by t naught minus j. So this negative and negative I can cancel out. I can obtain positive pi tau n pi tau divided by t naught. Okay, so this is the exponent. I want to change it to a cos or sine. So you must familiar with the Euler formula I told you before, right? So do you still remember what is the Euler formula? Okay, from here, can you guess which is it sine or cos is suitable in this case? In this question, do you think that either sine or cos is suitable based on the pattern of the exponent? Can you tell me? Can you guess? Either sine or cos. You just give a guess. Sine or cos, class?
Sign.
Why you say sine?
Fine.
Why you say sine? When you tell me sine, of course there's a reason. You don't tell me the answer in the module is sine, so you just tell me the sine. You have to know the pattern of sine and cos. Okay, if for the sine, what will you get? Sine theta is equal to 1 over 2j exponent j theta minus exponent j theta. Okay, if you look at this one, the sine theta, we are talking about the 1 over 2j. If the cos is 1 over 2 only, then if you compare with this question, okay, the solution that you obtained just now, okay, is you have the j. So this gives the hints that you have to choose the sine instead of the cos. Okay, so what if you write again? You write properly. So I rearrange it. Okay, I become 1 over 2j n pi. And the minus here, I multiply in. Okay, maybe I use different color. It's easy for you to see. Okay, red color. This minus I will multiply in. Okay, so I take out from the outside and multiply in. So I obtain minus exponent minus j n pi tau divided by t naught. Okay, this one multiply with this one, you will get positive. Okay, exponent j n pi tau over t naught. Okay, do you know why? Because because the sine I want 1 over 2j only. So this part is definitely suitable for the sine. And then you have the exponent j theta minus with exponent minus j theta. Okay, minus j theta. So this one, when I rearrange that this one, so this fulfill the cos theta. Okay, this fulfill the cos theta. Therefore, I can say that, so this 1 over 2j, this part 1 over 2j, okay, and this part I can change to the sine. So I left 1 over n pi sine. Okay, just now it already changed to sine, right? Sine what? So this is the just left n pi tau over t naught. Okay, up to here, are you okay? Maybe for some of you it's not easy to understand. Is it okay up to now?
Okay, doctor.
Okay,
Yes,
okay.
doctor.
Okay, so I left 1 over n pi sine n pi tau over t naught. So now I want to change to the sin. Okay, sin. So sin, okay, a sin af. This is the formula for the sin, which is equivalent to, let me see. Okay. So I want to change to sin. So a sin AF equal to sine pi FA divided by pi F. So this is again another formula for the sin. Okay, sin change to from the sine pi to change to the sin. Okay, here is the answer. Here is the sine. You want to change to the sin. How? Okay, you use this formula in the blue highlighted box. Okay, if you look at here, which part is the same? Okay, sine pi fa. Okay, you have the n pi. Okay, so this is the, you want to get the pi fa, right? So which one is the pi fa? Which one is, you need to define first. So this part pi f, this one is pi n. Okay, pi f, pi n. So this one okay, but this part is considered a lah. Okay, you just compare this formula with this formula with the equation that you obtained just now, because you want to match it. Okay, you want to change the sine into sin. Okay, so I compare this sine with this formula. So I found that the pi f, okay, this one is a pi n. Okay, then the a here, a should be the tau over t naught. So that's why I highlighted the a is tau over t naught. And then I have the pi f, right? This pi f, so it's a pi n here lah. Okay, so and then this one will change to this one actually fulfill. Okay, the equation I obtained just now is fulfill the formula of the sin. So I can change to sin. If cannot fulfill, you cannot change that, of course. So if I change, then I use this formula. Okay, so this one is a. So a, the one a I obtained is tau over t naught. Sin AF. Now a is tau over t naught. F is n. So this means that a is tau over t naught. The pi still refer to the pi. And then f is n. Now like this. So you obtain tau over t naught sin in the bracket tau n over t naught. This is already you change to simplified one. Okay, up to now, okay?
Okay, Doctor.
Okay, so this is the answer for the xn. Okay, this is the answer for the xn. So based on this xn, you can substitute into the xt. Okay, xt equal to the summation of the n from minus infinity to infinity xn exponent j n omega naught t. So this is the formula of the xt, where you already find the value of xn. Okay, so you just substitute in tau over t naught sin tau n over t naught exponent j n omega naught, you can change to 2 pi over t naught t. Okay, that's it. I think in the graph a little bit jump step. In the module a little bit jump step. If you notice from the graph, from the module page 112, there's some jump step over there that I think if you you can refer to my notes here. Okay, which one is jump step? You can write down the step, the procedure. If you can understand, that is fine. If you cannot understand, then you just write in the step-by-step basis lah. Okay, after that you can plot the graph. Okay, just now you already get the sin, right? scene. From the scene here, you actually can plot the graph. Okay, how to plot the graph of scene? You have the x. Okay, you have the sin x over x, which is equal sine x over x equal to sin x. Okay, so actually you can plot. Okay, I want to get, for example, I put 0. Okay, the x I put 0, and then I put pi over 2, and then I get pi, and then 3 pi over 2, and then I get 2 pi, and then I get 5 pi over 2, then I get 6 pi over 2, so it's 3 pi. So what will be the value? So how you can calculate? So you just for example, x0, you substitute sin 0 divided by 0, and then you get value 1. Okay, although you said that sin 0 divided by 0 is cannot, but for the L'Hopital rules you can. Okay, so the sin x is, or sin 0 is 1. Okay, sin 0 is 1, and then sin pi over 2 per pi over 2, you can calculate, but I can give you the answer here. This 0.64, this one is 0, then later you calculate back. Okay, you can try it back later. Then from here you can plot the graph. Okay, for example, this is 1. Okay, for 0, and then for pi over 2, okay, this is I write in the, instead of pi over 2, I write it is 1.57. So this is 2, 4, 6, 8, 10. Okay, so the first one, pi over 2 is 1.57, you get 0.64. Okay, approximately here. Okay, and then for pi, okay, is 0. Okay, something similar, somewhere here. And then 3 pi over 4, you get 4.7. 4.7, you get negative 0.21. Okay, negative 0.21. Okay, approximately here. And then 2 pi, you approximately you get 6.3. You get 0. Okay, and then 5 pi per 2, you almost get 7.8. Okay, 7.8, you get 0.127. 7.8, you get 0.127 is around here. And then 3 pi, you get 9.4 is 0. 9.4, you get 0. Okay, and then for the, okay, this one, if I plot, okay, just now I got one here, so I connect all the line. It's not easy to draw. Okay, approximately like this. So the left hand side also the same lah. Somewhere here, and then you got something here. Okay, somewhere here, and somewhere here. So okay, like this. So this is the sine x. Okay, this is the sine x. You can plot it. So any question for this one, class?
No, doctor, clear.
Clear? Okay, example 3.5 in your module. In your module, a square wave is given by xt equal to v from 0 to t naught over 2, and negative v is t naught over 2 to t naught. Okay, then find the Fourier series expansion of this signal. Okay, this one I think is also a lot of jump step. If you look at the module, perhaps it's not easy to understand. Okay, never mind, let me show you here. This is example 3.5. So again, you write down the formula. Okay, express this, you write down the formula. Okay, so xn equal to 1 over t naught. Okay, so from the, okay, the question is this one. Xt equal to v from 0 to t naught over 2. And then negative v is t naught over 2 to t naught. Okay, this is the question. So we need to follow this question. Okay, the range is from 0 to t naught over 2. Okay, the signal here is v. Okay, signal xt is v, and then exponent minus j. Okay, this part 2 pi n over no 2 pi n over t naught, you can change to omega naught t. Okay, for easiness. And then another part is 1 over t naught. Okay, the range is from t naught over 2 to t naught. Okay, now the xt is negative v. Okay, negative v. So now you can bring out the v to outside. So v over t naught. I try to write it one step by step so that you can understand better. Okay, I try to write it step by step so that you can understand better. So this one is t naught over 2 to t naught. Then you obtain exponent minus j omega naught t omega naught n. Okay, dt. Alright, so what else? So after this is integration, right? So you need to integrate. So integrate, you obtain. Okay, so this part you will be bring out. So it's negative j omega naught n. Then this part, after integrate, you obtain exponent negative j omega naught n t from 0 to t naught over 2. Okay, and then minus with v over t naught. So this is also part of the integration. Okay, so now, so far okay, class?
Okay,
Okay,
doctor.
doctor.
Okay, so now I want to change this t to t naught over 2. Okay, so what will I get? So for this part, omega naught is referred to 2 pi over t naught. Okay, and then I have the t, I change to t naught over 2. Okay, because I need to change the t to t naught over 2. So I cancel out this one. This one I will get pi only. And then for this one is 2 pi over t naught. This I change the t to t naught only. So this one will change to 2 pi. So v over okay, for this part, okay, this one also can change. Okay, t naught. Okay, t naught multiply with minus j 2 pi over t naught n. This one also can simplify. You obtain minus j 2 pi n for here. So v over minus j 2 pi n. Okay. And then for this one, you already substitute, right? So you obtain exponent minus j, just left pi n only. Okay, and then minus with exponent minus j0. Okay, and then continue minus this part. You substitute with t naught, you get exponent minus j 2 pi n. And then minus is positive. Exponent minus j pi n. Okay, this one t over 2 is pi n. Then this one will equivalent to this one, and this one you can combine. So you get 2 exponent minus j pi n. This one you continue. Exponent power of minus j0 is exponent 0, also equal to 1. This one is exponent minus j 2 pi n. Okay. Up to here, okay? Is there anything to understand?
Can.
Okay, doctor.
Okay, so now you need to test. Okay, test for the, because here you have to test for the odd and even. Okay, when n is odd and when n is even, maybe you could have the different value. So first of all, you need to test for exponent minus j 2 pi n. Okay, you test for this one. Okay, so exponent minus j 2 pi n. Okay, you convert to a cos and sine, you get cos 2 pi n plus j sine 2 pi n. Okay, can you tell me sine 2 pi n, sine pi n, no, sine 1 pi, sine 2 pi, sine 3 pi, what is the answer? You will get 0, right? Sine 1 pi, sine 2 pi, sine 3 pi, sine 4 pi, so you will get 0. But for the cos 2 pi n, when you substitute the n is 1, this means that cos 2 pi, cos 4 pi, cos 6 pi, all you will only get 1. So the value is 1 only for exponent minus j 2 pi n. Then you have to test for 2 exponent minus j pi n, which is this one. So 2 exponent minus j pi n, this is equivalent to 2 cos pi n plus 2j sine pi n. So this one you can obtain from the module. If you look at the page, what is the page? Page cos pi n. Page 118. Page 118. You look at the second, this one, you look at the second one, cos. Okay, there's a first part is a trigonometric integral. The second part is a value of sine, cosine, and exponential function. You look at the second cos. Cos n pi equal to, in the bracket, -1 power of n. So we need to use this one. So you will change to cos pi n equal to -1 power of n. Okay, so this sine pi n, you will also get 0. So, okay, now you can test for n when 2, this one is 2, right? So 2, -1 power of n. So what do you get? When 1, you get -1. When 1, you get -2. When 2, you get 2. When 3, you get -2. When 4, you get 2. So this means that the even, when n is even and when n is odd, is you got different value. So this means that when odd is v, okay, v, this one you go back to the here. Okay, so v over minus j 2 pi n. Okay, we are continue from here. V can minus j 2 pi n. So what do you get? Just now is 2 exponent minus j pi n, right? 2 exponent minus j pi n. This is the value you obtain. And then for this part, only you get 1. So you can substitute. For odd, you get -2. Okay, -2. -2, -1, -1. So this is -4 v divided by minus j 2 pi n. So this is also equal to j 2v divided by minus pi n. And then for even, v over minus j 2 pi n. Okay, if you look at here, the 2, for even, you get 2 only. So 2 minus 1 minus 1. So coincidentally, you get 0. So therefore, the xn you obtain is minus j 2v over pi n. Okay, so this one is also equal to 2v over n pi. Minus j here, this minus j here actually is refer to the 90 degree. J over pi, sorry, j over minus j is -90 degree because this is the imaginary. So minus j is 90 degree, -90 degree. So this is for n equal to odd. And then when n equal to 0, when n equal to even, you will get 0. Okay, it's 0. So this one you can express in the exponential form. So xt equal to the summation from n equal to -infinity and n equal to odd only. Okay, until infinity, you get 2v over n pi exponent minus j pi over 2 exponent power j n, like this. Okay, this is how you get the answer in page 114. Okay, or not, class? So I think there's a lot of jump step, so you can try to redo again so that you can understand all the things. Is it okay, class?
Okay, as for now, Doctor.
Okay, Doctor.
Any question to ask for this question? I know that exponential Fourier
No,
series
Doctor, no.
is not easy, but you have to try to understand that because you have to learn. From exponent change to cos, cos change to exponent. This one is about the exponential Fourier series. You have to change between exponent to cos sine, cos sine to exponent. This one is you have to familiar with this. And then you have to test for the even and odd value because n could be even and could be odd. So even and odd should have a different value after you change to the sine and cosine. So therefore you need to change to even and odd value. Okay, have to test for the even and odd value. Okay? Okay or not?
Okay. Okay, Doctor.
So I think time is almost the end now. So let's take the attendance. If you no question,